So Leetcode time for today. Next permutation. Um, so first of all, as usual, we take a look at which company is using it. So Facebook is the top company that made use of this question in the last 6 months, and 6 to 1 year. Okay, so we don't look at the data before the 6 months. So recent 6 months, Facebook used it 28 times based on statistics in Leetcode. So let's try to understand the problem first. So usually the first step in a coding interview is to try to clarify the question, try to understand it, and think about the edge cases. So question is next permutation, and implement next permutation which rearranges numbers into the lexicographical next greater permutation of numbers. If such an arrangement is not possible, it must rearrange it as a lowest possible order, sorted in ascending order. The replacement must be in place and use only constant extra memory. Okay, so we are going to do it in place, which means we can change the input parameter. Okay, constant memory. Okay, so I think we are pretty much clear about what the question is asking us to do. So think about the edge cases. So the edge case, it gives us this constraint. So the length of the input array is always between 1 to 100, and also each number in the input array is between 0 to 100. So I would say one edge case is what if the input array contains only one number. So just like example 4, then we don't need to do anything. And the next edge case I think is what if the input array is in descending order. Then pretty much the next permutation is to start over from the complete ascending order of the numbers contained in the input array. So I think that's pretty much it about how to understand the problem and think about edge cases. Then we can start to do the next step, so which is to find the solution. So in this part, it is pretty much for you to think about how to solve this problem and communicate with your interviewer about the solution to get an agreement before we start to do some coding. So I would say this one, it's pretty clear to me how to solve this problem because it was in the textbook. So let's give you a example which is more complex. Let's say if the input example is, let's say 1 4 9. Let's say it is 5 7 6. Let's say another 6. Let's say then 4 then 4. Okay, so this one, the input, the output, I would say is 1 4 9 and 6 4 5 6 4 5 6 and 7. So why it is that, and how we use algorithm to solve this one. So the first thing is to see to find the transition point. So find the transition point. How to find the transition point and what is a transition point? So we start over from the end of the input array. Try to see the point that is a transition. That is a transition point. So what we define a transition point is the number, the number that is smaller than the next number. So take this as example. So 4 is smaller than 6, so definitely not a transition point. 6 is equal to 6, not that one. 6 smaller than 7, so still it is in ascending order when we do a reverse traverse of the input array. And 5 is smaller than 7, so that's the transition point because at this time it start from ascending to descending if we do a traverse do a traverse of the input array reversely. So first is to find the transition point. So in this one, the transition point is this 5, which is at index 3. So the next thing is to find the next greater number in the subarray after the transition point and do a swap for the between the transition point and the next greater number. So the next thing is to find the next greater number in subarray. So I would say the subarray is input from index from the transition index to the end. So after we find the next greater number and we need to do a swap between transition. Let's say the next greater number has a index as next greater index. Then we will do a swap between the transition point and the next greater index. So it would be do a swap between input of next greater index and the transition index. Okay, so after we do that, the array would be something like this. So the next thing is to sort the subarray after the transition point from descending order to ascending order. So in this way, it's not a conventional sort because we just need to do a swap step by step from the beginning to the middle with the corresponding number. So let's say for this one, we do a swap for 7, 6, 5, 4. So first of all, we swap 4 and 7. And then we swap 5 and 6. And finally, we get the final answer we need to return. Actually, in this one, we just change in place, so we don't need to actually return it. And that's pretty much about the algorithm. So time-wise, it is going to be it's going to be linear. So all of n is defined as the length of the input array, and space-wise, we don't need extra space. Actually, we need extra space, but it's just constant. So constant in memory. Linear for the runtime and O1 as space complexity. Then let's do some coding on top of this solution. So for the coding part, we cared about the code correctness and code readability. So let's get started. So first of all, we need to find the transition point. Okay, so actually, first thing is not to find the transition point, is to deal with some special test cases. So let's say if nums the length is smaller than 2, then we simply return nums the length. We return nothing. I was stupid. So after that is the real logic. So first we define the transition index as -1. We are going to do a reverse pass for the input array. So I is starting from nums the length -1, I is larger than 0 minus I. So if there is a reverse order, which means if nums I minus 1 is smaller than nums I, then the transition index is equal to I minus 1. And if you try and find the transition point, then we simply break. Otherwise, it's going to cause some extra problem. So now we find the transition index. So if the transition index exists, is now equal to 0, which means then we need to do whatever the step we talked about. Otherwise, we just need to reverse the whole input array. So let's define a helper function. Let's say we reverse the input array from index I to index j. So in this way, it is beginning is 0 and end is num dot length minus y minus 1. Okay, so now in how to implement this if branch. So the if branch is about to find the next greater number for it. So let's say next greater index. So int next greater index is equal to, let's define it as transition index plus 1. So again, a reverse other pass. So as larger than transition index minus I. So if nums I is larger than nums transition index, then that's the next greater index is equal to I, then we need to break it. So now we find the transition index and the next greater index. We need to do a swap for it. So let's define a helper function to swap two numbers in the input array. Then we need to do a reverse for it, starting from transition index plus 1 until the end of the input array. Now is the time for us to implement the helper function. So void swap. So int array nums int, let's say let's use just I and j because it's just meaningless. So int temp is equal to nums I. Nums I is assigned with nums j, and nums j is equal to temp now. So let's finish the reverse helper function here, which is about to reverse the subarray. Nums begin and end. So we start from begin and until we hit the middle, which is begin plus end divide by 2. So actually we should be plus 1 here. Plus I, and we would do a swap between I and I'll say that it should be end minus I minus begin. Like how I minus begin is how far the current index is from the beginning. So I would say that's it. Let's go through this input example to see how it works. So the last part is about testing. So we will need to go through one test case manually to explain how this code works, and then we would try to increase the test coverage after all to see what test cases that could cover different branches. So let's go through this example. Let's say definitely not this if branch because it's larger than 2, the length of the input is larger than 2, and then we try to find the transition index. So now we find the transition index as equal to this is equal to I is larger is here. So I minus now index at I minus 1 is smaller than at index I, then it should be what am I looking at? So actually it should be input is this. So the transition index now is 3, 0, 1, 2, 3, and we jump into this if branch because transition index is not equal to -1, and we find the next greater index. So next greater index is initialized as 4, and we are going to jump is this for loop to see which one is the next greater number. So I is larger, if nonce I is larger than that, the next greater number is set as I, and we do the reverse outer traversing of the input array. So starting from 4 is definitely not larger than 5, and 6 is actually larger than 5. So the next greater index is 0, 1, 2, 3, 4, 5, 6. It's actually 6. And then we do a swap between the number at index 3 and index 6. And after swap, it would be we are switching this one and this one, and after the swap we are doing a reverse. So the reverse is about starting from transition index +1 to the end of the array. So this would, after this one, it would be, so first of all we are going to reverse 4 and 7, of course, and then we are going to reverse 5 and 6. So I was checking whether this one is correct. So let's say the index here, so we are going to reverse the begin is set at 0, 1, 2, 3, 4. 4 towards reverse 4 towards 5, 7, 4, 5, 7, 4, 5, 6, 7. Okay, 6, 7. So we are calling reverse nums 6 until 7. So we need to do two swap operations. So we start from, so essentially I should be given 4 and 5 before we stop. So the ending condition is 4 plus 7, which is 11, divided by 2, then it is 5, then plus 1 is 6. So okay, so I think it should work. Let's run the piece of code to give it a shot. Okay, it's accepted. So then we think about some other test cases. So for example, we can think about whether it is going to work correctly if the input array is completely in descending order. It should work because we don't find any transition index here. Then we jump into this else branch, do a complete reverse, and let's submit this piece of code. Okay, so accepted. Now we should be good for this specific question. Yeah, so like I said, first of all, clarify the question and try to understand it, think about edge cases, and then the second step is to find a solution to cover every cases so that it won't be broken by some specific corner cases. Then third one, in the coding part, you turn your idea into solid code correctly and also in a readable way. And the last one is about testing to run through your code manually, explain how it works to your interviewer, and also think about the edge cases for the test coverage to cover different branches. Okay, so that's it for this video we solved the next permutation problem, which is asked frequently in Facebook coding interview. I hope you enjoy it, and thanks for watching. If you like it, please subscribe to this channel, and I'll see you in the future.